Okay, so let's check out this second video now. So we already did practice problems 1 through 4. So we practiced calculating an empirical formula. We practiced calculating the formula of a hydrate, which would be more from lab data. And then we practiced what to do with percentages. And then we practiced how to calculate a molecular formula. So let's just do this a little bit more. If a sodium carbonate hydrate is heated and the mass changes from 4.31 grams to 3.22 grams, what is the formula? Now remember, when we heat up a hydrate, we're going to basically evaporate away that water. So we should expect to see the mass go down always. So for this problem, again, I'm going to work up here to give myself a little bit more room. It said I had 3.22 grams of my sodium carbonate without the water. And now the value of the water, again, is going to be the difference between the initial and the final. So that volume that went down, that represents the water that was evaporated away. So the difference between 4.31 and 3.22 grams is 1.09 grams of H2O. Now, as always, let's convert these grams to moles. So the molar mass of sodium carbonate is about 105.99 grams. And water is 18.02 grams per mole. So we get about 0.03. Notice here, for these answers right here, I'm just kind of getting an approximate value because we're going to be dividing by the fewest anyways. And no matter what, we got to end up with whole numbers. So I'm not really worried about sig figs. And for this one, we get about 0.06. Again, the formula of the substance attached to the hydrate should always be the lowest value here, and that makes sense. So let's divide each of these by 0.03, divide by the fewest moles. This one should typically be 1 here, and then this is going to be 2. So this means that we have a 1:2 ratio, and the formula of our hydrate would be Na2CO3. We should just write like a dot here, 2H2O. This is another good practice problem if you're looking at how to do the calculations for your hydrate lab report. Let's look at question 2 now. Calculate the molar mass of NutraSweet if it's 57% carbon, 6.2% hydrogen, 9.5% nitrogen, and 27.2% oxygen. So remember, our tip is to always just turn these percentages into grams and assume we have a 100-gram sample. So that would mean we have 57.1 grams of carbon in this hypothetical 100-gram compound. We have 6.2 grams of hydrogen. We have 9.5 grams of nitrogen. And we have 27.2 grams of oxygen. First step, let's always turn these grams into moles. Okay, so for the carbon, we end up with about 4.75. For the hydrogen, we end up with about 6.1. For the nitrogen, we end up with about 0.678. And for the oxygen, we end up with about 1.7. Now, I think a common mistake, a misconception, is that we look at these as our ratios, but we always need to divide by the least value. So make sure to do something to identify that. Maybe you always circle one of these to get in the habit of that. So 0.678 is the least value here, so let's divide all of these by 0.678. So we divide 4.75 by 0.678 and we get about 7. Remember, if this was like 7.1, I'm just going to say it's 7. If it's 7.5, I would leave that 5 because we probably have to multiply everything by 2 at the end. So for the H, we get about 9. For the nitrogen, we get 1. One of them is always going to start out being a 1 here. And then for the oxygen, we get 2.5-ish. This one you can't just round up or down. It's a little too far away. So once we get that 2.5, this tells me that we've got to multiply all these values by 2 to turn all of them into a whole number. So we get 14, we get 18, we get 2, and we get 5. So it looks like the formula for this NutraSeq compound, the empirical formula, would be C14, H18, N2O5. Pretty big compound. This is about as hard as they get, though. Okay, let's look at the last example here. If we found a compound with a molar mass of 42.09 grams, that's the molar mass of the molecular formula, and it had 85.6% carbon and 14.4% hydrogen, what's the molecular formula for the compound? So let's start by turning the percentages into mass. We have 85.6 grams of carbon in that 100-gram sample, and we have 14.4 grams of hydrogen. Let's turn these into moles again. This is about 7.1, this is about 14.2. Let's divide by the least value in moles. This is going to be 1, this is going to be 2. So it looks like our empirical formula is CH2. CH2 has a molar mass of, so guess what time it is in the day, and guess what day it is. We took a 10-second TO here, listen to the music. This molecular mass of CH2 is about 14.03. Let's take the molar mass of the molecular formula, 42.09 grams per mole. Let's divide it by that 14.03 to get our multiplier. So this multiplier is 3. So we're going to have to multiply each of these values by 3. And remember that there's essentially 1 carbon there. So the formula for our molecular formula would be C3H6. Hope this helped.